Welcome back, everyone. Today we're going to be doing a deep dive on a really fascinating topic, photonic qubits.
It's a pretty wild area.
Yeah, I mean, these are the potential building blocks for the quantum internet.
Exactly.
And we'll be looking at photonic qubits, Lichtbasierte Quantenrevolution by Jorgo Schneeppert.
Schneeppert lays out a really good foundation for understanding how we can basically use light to potentially revolutionize computing and communication.
Absolutely. So let's just dive right in and start with the very basics. What exactly are photonic qubits?
So, we talk about bits in the digital world, right? Like the ones and zeros.
Right, the on or off switches.
Yeah, exactly. So think of a photonic qubit as a bit with a quantum twist.
Okay, how so?
Well, instead of just being on or off, it can be both simultaneously.
Both at the same time.
Right. It's like a coin spinning in the air. It's showing both heads and tails at the same time.
Oh, I see. Okay, that makes sense.
Yeah.
So how do we harness this both at the same time potential?
Well, that's where the unique properties of photons come in. Schneeppert highlights how we can use photons to represent quantum information. And, one way we can do that is by using the polarization of the photon. So it's like which way the light wave is wiggling.
Yep.
And we can encode data in that wiggle.
Yeah. So we're not just talking about the photon itself, but about specific characteristics we can manipulate.
Exactly. And one of the big advantages, as Schneeppert points out, is that photons experience very low loss as they travel. So they can transmit information over incredibly long distances without losing energy. And of course, they move at the speed of light.
Right. Super fast.
Exactly.
Okay. So we have speed, we have distance, we have low loss. I'm seeing the appeal for building a quantum internet. But what about noise from the environment? Can these qubits hold up against all that?
Yeah, that's a good question. You might be surprised to learn how robust photonic qubits actually are. They have very weak interaction with matter, which actually makes them less susceptible to errors from things like temperature changes or electromagnetic interference.
So it's like they have a built-in shield against all that chaos.
Yeah, you could say that.
That's fascinating. So how do we actually make these qubits in the first place?
Yeah, so Schneeppert outlines a few different methods. One is called, and this is a mouthful, spontaneous parametric down conversion. Basically, you use a special crystal to split a high-energy photon into two entangled photons. And these photons become linked. They share a kind of destiny, no matter how far apart they are.
Entangled photons. That just sounds so bizarre. Okay, so now we have these qubits. How do we control them? I can't imagine that's an easy task.
Oh, no, it's definitely a challenge. But Schneeppert describes how researchers are using some fascinating tools to manipulate these qubits. For example, waveguides. These are tiny channels that guide light.
Yeah.
And optical resonators that can amplify light signals. These tools allow for incredibly precise control over the photon's behavior.
So it's almost like creating these little obstacle courses for the photons to navigate.
Yeah, exactly. And by manipulating these obstacles, we can actually perform computations using photons. Schneeppert talks about something called linear optical quantum computing, or LOQC for short. And this approach uses things like mirrors and beam splitters to carry out quantum calculations.
Wow, mirrors and beam splitters doing quantum calculations.
Yeah.
That just blows my mind. But I'm guessing LOQC isn't without its challenges.
Oh, you're right. Schneeppert points out that while it relies on pretty well-established technology, it's actually probabilistic.
Okay, what does that mean?
It means we're not always guaranteed to get a specific outcome. It's a bit like rolling the dice, but with quantum mechanics.
High risk, high reward, right?
Right.
And I know from Schneeppert's essay, there are a lot of brilliant people tackling these challenges head on.
Yeah, absolutely. He mentions some companies like Xanadu and Sequantum and institutions like the Chinese Academy of Sciences.
Oh, wow. Some of the big players.
Yeah, they're all pushing the boundaries of photonic quantum computing and, finding these really innovative ways to generate, control, and entangle photons. It feels like we're getting closer and closer to a future where a quantum internet might actually exist.
That is beyond exciting. Okay, let's be realistic for a second. What are some of the obstacles standing in the way? What are the downsides?
Well, one of the major hurdles that Schneeppert highlights is scaling these systems. It's just not easy to manage huge numbers of these incredibly delicate qubits, especially while trying to maintain their both at the same time properties, which are crucial for quantum computing.
Yeah, so it's like building a house of cards in a hurricane.
Pretty much.
So what are some of the things that threaten that stability?
So one of the biggest risks is something called decoherence. Basically, it's when the quantum states start to collapse and lose their special properties, and that leads to errors. Schneppet explains that the more qubits you add, the more susceptible the whole system becomes to these errors. It's definitely a huge challenge. But Schneppet does talk about some potential solutions, like quantum error correction.
So like a way to constantly monitor and fix errors as they pop up.
Yeah, exactly. Sort of like a dedicated repair crew for our quantum house of cards.
I like that analogy. Okay, so even if we manage to scale these systems and keep them stable, how do we integrate them into our existing technology? I mean, it's not like we can plug a photonic qubit into our laptop, right?
Right. Schneppet brings up this really important point. Integrating these really advanced photonic technologies into our existing infrastructure, especially our fiber optic networks, is a huge challenge.
Are we talking about like rebuilding the entire internet from scratch?
Well, it might not be that drastic. Schneppet suggests that hybrid networks, which combine both classical and quantum communication, could be a more practical approach.
Okay, so a blend of old and new.
Exactly. And he also talks about the research being done on chip-based technologies, potentially miniaturizing these complex systems and making them more compatible with current electronics.
That makes sense. So it sounds like there are ways to bridge the gap between current technology and this quantum future. And speaking of bridging gaps, Schneppet also introduces the concept of these hybrid systems. What exactly are they, and why are they so exciting?
Hybrid systems are really interesting. The idea is that instead of just using photonic qubits, we could combine their strengths with other types of qubits.
Like what?
Well, Schneppet mentions superconducting qubits, which operate at super low temperatures.
So each type of qubit brings its own strengths to the table.
Yeah, it's like assembling the ultimate quantum team. Superconducting qubits are really good at doing complex calculations, while photonic qubits are awesome at transmitting information over long distances. So Schneppet kind of paints this picture of a future where we do these really complex computations in one place and then instantly share those results across continents.
All thanks to the power of light. It's almost like science fiction. Harnessing quantum mechanics to solve problems and communicate at incredible speeds. What are some of the potential downsides we need to be aware of?
Schneppet does point out that one potential concern is disruption of existing industries. The transition to a quantum internet would likely require huge changes in infrastructure and technology.
Right, and those changes could have unpredictable consequences, both economic and social.
Exactly. Schneppet stresses the need for careful planning and making sure the benefits of this new technology are available to everyone. It's not just about building faster computers or more secure networks. It's about making sure these advancements benefit humanity as a whole.
Well said. Schneppet's essay really highlights the amazing potential of photonic qubits, but also the importance of responsible development. What are your thoughts on where this field might be headed in the next few years?
It's hard to predict the future, but I think we're going to see a lot of breakthroughs in quantum error correction, making those systems much more reliable. And I think we'll also see more progress in integrating photonic technologies into existing systems, which could lead to some practical applications. And as Schneppet suggests, I think these hybrid systems combining different qubit technologies are going to be a big deal for quantum computing and communication.
It really does feel like we're on the cusp of a technological revolution. It makes you wonder what other possibilities might be out there as we delve deeper into this quantum realm.
That's the beauty of scientific exploration. The possibilities are almost endless. Who knows what incredible discoveries await us in this quantum future?
I can't wait to find out. Schneppet's essay has been a fantastic guide on this journey, really walking us through these complex topics.
I agree. Jorg or Schneppet does a great job of explaining the technical details and also talking about the bigger picture.
I'm definitely left with a sense of awe, but also a little bit of healthy skepticism. Awe at the potential and skepticism about the challenges we have to overcome to make this vision a reality.
It's a really exciting time to be following this field. So for anyone listening who wants to learn more, where should they start?
Well, definitely check out Schneppet's essay, Photonische Qubits, Lichtbasierte Quantenrevolution. It's a great place to start. And definitely look into the work being done by Xanadu and Sequantum.
Yeah, and don't forget about all the amazing research happening at universities around the world. There's so much information available online.
So to wrap up our deep dive into the world of photonic qubits, let's leave our listeners with something to think about. We've talked about the potential for a quantum internet to change communication and computation, but what about its impact on something like artificial intelligence? Could these photonic qubits be the key to unlocking even more powerful and sophisticated AI systems?
That's a great question, and I think it's one that will be debated and explored for many years to come. The connection between quantum technologies and AI is still pretty much uncharted territory, but I think there's a lot of potential there.
It's a really exciting thought. Well, that's another deep dive completed. We hope you've enjoyed our exploration of photonic qubits and the incredible future they might hold. Stay curious, everyone. It really feels like we're standing on the edge of something massive right now. And Schnephat's essay has done such a great job of walking us through this world.
Yeah, Jirgo Schnephat, he really lays it all out there, both the amazing potential and, the hurdles we need to clear.
I'm definitely walking away feeling a sense of awe, but also that bit of skepticism that I think we always need to keep in mind.
It's good to have both. That balance is important when we're talking about a field that's evolving so rapidly.
So anyone listening who's now completely hooked on photonic qubits and wants to go deeper, where do we point them?
Schnephat's essay is a great foundation. It gives you a solid understanding of the basics and some of the big challenges. Beyond that, I think checking out the research from some of those organizations we talked about would be great.
Right, like Xanadu, Sequantum, even the Chinese Academy of Sciences. Their work is fascinating.
Definitely. And don't forget all the research happening at universities. There's tons of information out there online.
So much to explore. Okay, as we wrap up, let's leave our listeners with a question to ponder. We've talked about the potential of a quantum internet to revolutionize how we communicate, how we compute. But what about its impact on artificial intelligence? Could photonic qubits be the key to unlocking even more powerful AI systems?
That's a really interesting thought. And honestly, I think it's one that's going to spark a lot of debate and research in the years to come. The intersection of quantum tech and AI, it's a pretty wide open field.
It's mind-blowing. Well, there you have it. Another deep dive complete. Hopefully you've enjoyed exploring the world of photonic qubits with us. And who knows, maybe they really will be the key to the future. Until next time, keep that curiosity alive.